So hopefully this video will be about how to clean up the mobile temperature data in R. No guarantees, it's kind of complicated, so bear with me. First I'll show you Baltimore, which I've already done, and then I'll try to implement Cincinnati, which is a very different starting point in terms of the data structure, and you can hopefully go from there. So Baltimore, I'm saying we are starting from the pre-merged data. So there'll be 3 shapefiles, one for each time of day. So you want to find where that is. So in this case, it's in one folder in the vehicle traverse shapefiles, afternoon, AM, PM. In other cities, it will be different, but you'll need to find those. And then you go to this mobile data cleaning R script that I just made. Let's start things up. So set your directory. Feel free to implement the home thing here. I'm trying to do your Control-Shift-H. So we're setting it to the city, specifying the city name. EPSG code, so what is that? That is the coordinate reference system. That's like how the geographic data are displayed. So I can quickly show you that. This is getting a bit more into geography stuff here. So what am I going to do? I'm going to search for the city first, and I'm going to look for what is the UTM zone for Baltimore, Maryland. So UTM is this actual coordinate system. And so all we care about is zone 18. The S is very confusing. Ignore that. Hate to have all these caveats, but such is life. So now we know that it's zone 18. And we know that it's above the equator and thus north. That's why this S is extremely confusing. So UTM zone, so now we have EPSG for UTM zone 18N. This is the number, EPSG 32618. You can see the 18 is the thing that aligns with the actual zone number. The 326 just means that it's UTM. So all of the ones we do are going to be 326 and then something. So I'm not going to get into the what's and the whys here. It takes a GIS course to do that. So just try to do that, those 2 steps, and ask questions. So we've got our EPSG code. I've found the trip date using the metadata, the PDFs that you've already done. I've got the location, the path names for AM, afternoon, and PM. Set all those. And I'll set the file name for my output, which is going to be the city, Baltimore, all temps, UTM 18N. So that UTM zone in the northern hemisphere. Check field names and merge. Hopefully you won't need to do anything in this, but you might. So we'll load the 3 shapefiles and we'll compare all the column names. They should all be exactly the same. And so I'll just show you are the column names the same? Yes, true. All of those column vectors were the same. And so I can run this code, and that is going to add in a traverse ID column if that doesn't already exist. Well, it's going to do it no matter what. And it's going to R-bind those together. And so at this point, it would be good to take a look. We'll do that later, actually. Sorry. Never mind. Moving on. So here's where it gets very specific, but I think it's still good to do this in R. So we're going to have one little section for each city. It'll just be copying and pasting. So this is our Baltimore area. First, we'll look at where we're at here, and just to see which columns we have. do we have a reasonable number of features? I'm going to look over here at all temps. I've got 147,000, which seems a bit high, so that might be something we'll need to look at later. And here's the key cleaning up code. So all of the resultant column names should be the same for each city, but what makes them may be different for each city. And so that's based on looking at the header here. So I know, for example, I know that speed just equals speed because that's already in there. I know that time equals loc time here. So these are the things that might change. Unique ID should not change. That should be the same every time. Date should be the same every time. Temperature certainly will be different many times, and sometimes you'll have to update this mutate to convert from Fahrenheit to Celsius. And then finally, we're going to keep only the columns that we care about to clean everything up. So let me run that. And so now we've got a much cleaner data set, a unique ID, our date, time, speed, temperature in Celsius, traverse ID, and then the actual point locations that are currently in latitude and longitude. Now we're going to convert this to UTM, Universal Transverse Mercator. This is just a different way of projecting spatial data that I won't go into, but it's going to make use of that EPSG code. This is just for consistency's sake. And now we'll take a look at what we have. So I'm going to plot just the fifth column, which should always be, at this point, TC. And we look, okay, this looks weird. It has multiple cities here. We have DC and Baltimore in this data set. So just one more thing to clean. Hopefully we won't have to do that for other cities. I'm guessing we won't, but been wrong before. So this code I've implemented and would not expect you to do that, to filter out the DC points based on their location. And so let's look again after that filtering based on how far north the points are. And now we just have Baltimore. Finally, I'll write out the output and just revisiting the file name, Baltimore, all temps, and the UTM zone. Data set already exists because I was doing this earlier and forgot to delete it. No big deal. Let's just see what this looks like. So it would come in here to this folder. I might need to refresh for it to show up. And then I would want to bring it into my Baltimore folder. And these should be put in alphabetical order so they're easier to find. And you see, okay, it shows up just in Baltimore. And I'm going to look at the output. And that is wrong. Oh, sorry, I just added the wrong thing entirely. So this was what I just wrote. So we'll throw this in Baltimore and look at the attribute table. And this looks good. We got our columns look good. We got our unique ID. I'm just going to sort that to see. Oh, there's some that went away because we got rid of Washington, D.C. So that's fine. As long as there's a unique ID, it's okay. We got our traverse ID. We have everything. So I think this looks like it's in good shape. So let's look quickly at Cincinnati. So I would want to go and see, okay, we got our traverses folder. And in this case, they're each in different folders. We want the temperature ones, not the relative humidity ones. So we've got our PM, AM, and afternoon. And for me, it's easiest to just grab the paths here. Traverses, Cincinnati. AM, traverse, temp, I'll start with. And so I'm going to grab everything that's after the city. Paste in this actual name. You can do this your own way. So now let's start again. I'm going to get rid of everything. And just because because I've got it here, I'm going to throw in this AM path. The slashies are going the wrong direction, but I'll fix that momentarily. So AM afternoon temp. If you have a better way to do this, that's fine, but don't spend too much time on it. It's not the priority. Okay, now I'm going to replace all my slashes. You can see I got my find and replace set up here. All right, so now we need to reset this stuff. Cincinnati. And we need to look up the UTM zone. So UTM zone for Cincinnati, Ohio. And just going to click in here. Gives you the coordinates. Doesn't tell you the zone, of course, which is the most important thing. Stuff kind of annoys me. Okay, I just saw it there. UTM zone 16, and again, we're ignoring the S. So 16, great. EPSG for UTM zone 16 north above the equator. And that's just 32616. So you can see it's the same idea. We're just moving from 18 to 16. I do need to, every time I clear the data, I do need to run the libraries again because I have this select code in there. So maybe that should be moved somewhere else, but that's what it is right now. And what is the date for Cincinnati? August 10th, 2020. August 10, 20. So my trip date, load the paths, and change this to Cincinnati, and we're in zone 16 instead. Okay, so now we're ready to roll. So let's see if this works. It does not, but it's just because I can't find the data. Oh, I did maybe change the working directory. Thought I did. I did not. Okay. We'll just troubleshoot on the fly here. There's no dot there. There we go. It was simply, well, it was two things. I didn't get in the working directory yet, and I didn't have the proper setup for these paths. So now they're loaded. Let's see what happens. Okay, I think that's good. We have an all temps data layer, that's 75,000, and you can see the numbers of all the input data sets, so that all looks appealing. And now I'm going to take this whole, let me get rid of this. So I'm going to take all of Baltimore, and I'm going to copy it and paste it, and this is now our Cincinnati section. And this is where you do have to make a lot of changes. So we'll get rid of that filtering code, And so first we'll look at the header and see what we got to work with. There's a lot more information in here, but there's more things to change also. So first of all, TC, we do have that. So TC equals TC. UID stays the same. Speed looks like this one, speed in kilometers per hour. So we want to change that. So let me comment. Well, I won't do that here. It should be in miles per hour, always. So that's going to be divided by 1.6, I think. I'm going to check. Yes, I've confirmed that that is correct. So time. So they've got a lot of time information in here now. And I'm seeing this date time TC and date time LC. So what's the difference here? Well, first of all, we see that we already have it. Traverse ID is AM, so this is the morning. TC, I believe, is universal time from London, and it's 10 a.m., which is too late. That's not the real time. So locally. LC is probably local time, and you can see that it's 6 a.m. So this is what we want. These are the things you got to just try to keep your eyes on. Like the times should be early in the morning, middle of the afternoon, and like around 6 p.m. or so for PM. So we're going to use this one. So in this case, we have this date time is actually both date and time, which could be fine, but it's like we just got to try to be consistent. So we're just going to try to keep only the time. So what I would do here is first of all, I'd want to see what is the data type currently for this. So I do structure of this data set, and we can see this guy is character. So that's fine. So that just means we can then take a substring of each of these to only keep the time. So we don't have to worry about actually like any kind of time manipulations. So I would just count and say, okay, the substring starts at 4, 5, 6, 7, 8, 9, 10, 11, 12, and goes to 19. So 12 to 19 is just the time. And so I'm going to put in time as substring of that date time, local time field from starting at 12, ending at 19. Date is fine, and then this select keeps only the stuff we want. So let's see what happens. Let's see what it looks like. Run this header. So we've got a date, we've got the time properly substringed, speed, TC, traverse. So this looks pretty good. So I'm going to transform it to the proper UTM zone, and then let's take a look at the temperatures. Okay, it looks like at least it's one coherent city rather than multiple cities. And let's write this guy. Okay, why did you fail? Let's go back and look at my output. File name. Oh, because I didn't actually update the path. My bad. That's still the Baltimore path there. All right, let's see if this works. Yep, that's working. So now we'll go confirm that everything looks good in ArcGIS. I will go into this the folder that I just saved it in is right here. Oh, it doesn't show up. What do? You can refresh that, and now you see Cincinnati all temps UTM 16 does show up. Put it in my Cincinnati group, and we will travel to Cincinnati. Okay, looks fine. You know, the data's there. It overlaps the other data. That's good. And let's just look at the attribute table, and date, time, speed, TC, traverse ID, all looks good. So that is the somewhat complex plan, but I think it's what we have to do with this kind of data.